Hello everybody, welcome to an introduction to factoring polynomials. In examples 1 through 3, we're asked to factor each of these algebraic expressions by finding the greatest common factor. So let's look at example number 1, and we'll go to the whiteboard and work this out to understand what we have to do to factor out this polynomial, or in this case binomial, using the greatest common factor.
Example number 1, we're asked to factor 12a squared b plus 90a squared b squared c. So let's first look at each term. So we have 12a squared b, and we're going to break it down into its basic components. We can break down 12 into its prime components of 2 times 2 times 3, and then a squared is a, and then b. And similarly we do for 90, a squared, b squared. And this we can break into prime components, 3 times 3 times 5 times 2. And then we have a for a squared, and b for b squared, and then finally c. Now what we want to do is we want to see what parts they have in common. Well, both 12a squared b and 90a squared b squared c have a 2 in common. And then both of them have a 3 in common. They also have 2 a's in common. And then they also have 1 b in common. So we see that they have 2 times 3 times a times a times b in common. And this is the factor, or their greatest common factor. So we see that that is equal to 6a squared b. Now we want to put it all together with this. So we have what's left over. So we have 6a squared b and what's left over from the 12a squared b is 2, and that's pretty much it. And then from the 90 we have plus 2 times 5 is 15, and then we have the BC. Now, of course, if you're not sure if this is correct, what you want to do is you want to factor this to make sure that it's correct, and that would be a way to check. So that will give you 12a squared b, and that would be the same as here. And then plus, if we factor that, 6 times 15 gives us 90. And then we have a squared b squared c, which is what we have here. So that means the way we factored it is correct.
Having worked it out on the whiteboard, we found that we could factor this as 6a squared b, and the whole thing is multiplied by 2 plus 15bc. So 6a squared b is the part that both these have in common, and then the 2 plus 15bc is what is left over. In example number 2, we're asked to factor this trinomial. So let us go to the whiteboard and work out this trinomial in a similar manner.
In example number 2, we have 32 m squared n cubed minus 8 m squared n plus 56 m cubed n squared. So here again, we want to take each term and find its basic components and compare them to see what they have in common in order to find the greatest common factor. So let's do this. So let's start out with 32 m squared n cubed, and that's equal to 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 and 4 is 16, and 16 times 2 is 32. Then we have m, 2 m's from the m squared, and then n from the n cubed. And from the negative 8, we have here negative 8 m squared n is equal to, and this is very important, we factor out the negative 1 times 2. Negative 1 is one of the parts, times 2 times 2 times 2, and then m squared m, and then n. And then finally 56 m cubed m squared, and that's equal to 2 times 2 times 2 times 7 m, and then n. So now we want to compare all those three terms and see what they have in common. Well, it looks like 1, 2, 3, 1, 2, 3. All of them have 3 2's. So here are 3 2's for all three of them. Then let's look at the m's. Well, they all seem to have 2 m's. 1, and then 2 m's. And they all have 1 n. And they all have 1 n. So we see that what they have in common is 2 times 2 times 2, m, and then n. And that's equal to 8 m squared n. And that is called the greatest common factor. So we take this greatest common factor and we put it on the outside, m squared n, and then we look at what's left over from each term and write each one inside a bracket separately. So we have 2 times 2 n minus 1. This is very, very important. And then plus 7mn. And that's the same thing as writing 8m squared n, 4n squared minus 1 plus 7mn. Now it's very important that you put in that minus 1, or if it would be a one term, it would be if it was exactly the same, because remember, when we check, we're going to factor each of these, and we want to make sure when we distribute it, we get all three terms back that we originally started with. And this negative 1 will be distributed to make our second term.
We found that the greatest common factor in this trinomial was 8m squared n, and then we would multiply it by the rest of this to get this back. In example number 3, we're asked to factor this particular trinomial again by finding the greatest common factor, just like we did in 2. So let us go over to the whiteboard and work this out in detail.
In example number 3, we have 20 a, b, c plus 15 a squared c minus 5 ac. And we do the same thing as we did in the other two examples. 20 a, b, c is equal to 5 times 2 times 2 a, b, c. 15 a squared c is equal to 5 times 3 times a times a times c. And then we have finally negative 5 ac, and that's equal to negative 1 times 5 times a times c. So now we look for what they all have in common. Here are the 5s that they all have in common. And then they have a's in common, one a in common. And it turns out that they all have one c in common. So the greatest common factor is equal to 5ac. And again, we put the 5ac outside a bracket. And then what's left over here in the first term is 2 times 2 is 4. So I'll write that 2 times 2, b plus 3a, and then minus 1. Now remember, the one's very important for when you check to distribute the last term. So we have 5ac is equal to 4b plus 3a minus 1. And of course, to check, you just distribute this. So you'll get 20 a, b, c. This next term, when we check, we'll get 15 a squared c. And then finally, and this is why it's so important to remember those ones for the last term, minus 5ac. So there we get back our answer in our check.
We found that after we worked this out in detail, that the greatest common factor of these three terms was 5ac, and then we would multiply it by 4b plus 3a minus 1 to get back this trinomial. In example number 4, we're going to factor this expression. So I'm going to show you how to factor something that looks like this on the whiteboard.
Let's look at example number 4. And here we have 3x in bracket 5x minus 2 plus 5x minus 2. Now we see that the terms here and here, the ones in the brackets, are the same in each of these terms. So like we did before, we can take these two since they're the terms and we can factor them out. 5x minus 2, and then the parts that we have left over, we can put in another bracket, 3x plus 4, and there we have it. We have factored this particular equation out.
What we just did in example number 4 is something called factoring by grouping. And what we got when we used this technique is we got 3x plus 4 times 5x minus 2. So now that we understand how we do factoring by grouping, we're going to factor each of the following expressions by this technique. So let's look at example number 5 and go to the whiteboard to work it out.
In example number 5, we have ax plus ay plus 2bx plus 2by. Now let us look at these terms. And we're going to actually group these terms. So we're going to look at this as a group and this as a group. And so we're going to end up factoring out what this particular ax plus ay have in common. And we see we can factor out the a. So we can rewrite this one as ax plus y. Similarly, for this group here, we have 2bx plus 2by. And here we can factor out the 2b from here. And we can add that 2bx plus y. And like in example 4, we have the x plus y in common, so we can now factor that out, x plus y, and then put it in the next bracket, what we have left over, a plus 2b, and now we have factored this into this particular expression.
We saw on the whiteboard that we can put it into this form that gets it prepared to factor by grouping, because we see that we have x plus y and x plus y here, so we can put that in one bracket and then a plus 2b in the other bracket. In example number 6, we're asked to factor 9x squared minus 15x minus 6xy plus 10y using the technique of factoring by grouping. So let's go to the whiteboard and work this out.
In example number 6, we have the terms 9x squared minus 15x minus 6xy plus 10y. So we make our groups. So here's a group, and here's a group. So here for this group, we have 9x squared minus 15x. And here we can factor out 3x. So we factor out 3x, and we get 3x times 3x minus 5. And then for this one, well, we have that minus, but we want to make sure that when we factor out something where we have that minus sign, that when we use the distributive property to multiply it back in, we get the right answer. So I'll just do this on the side here to show you what I mean. So we have negative 6xy plus 10y. Now I have 2, because 2 goes into 6 and 2 goes into 10, and I also have the y. So I'll factor out 2 and y. But I also must factor out and be very careful when I factor out, let's say, the negative, because when I want to factor it back in, I want to make sure that I get the right sign. So here I'll have 3x, but for this one I have to put minus 5. So when I end up factoring this back in, I will get negative 6xy, and then a negative times a negative 5y. So negative times a negative, negative times a negative, I'll get plus 10y. And that's why I have to be very, very careful with my signs. So now I can rewrite it here, 2y times 3x minus 5. And I wrote a little bit clear. I made a little mistake, a little blob there accidentally. So now I have everything in its group. And you notice how I have this one and this one are the same, so I could factor that out. So now I have the 3x minus 5, and then I just put in the next bracket what I have left over, 3x minus 2y, and now this particular expression is factored.
So we found on the whiteboard when we worked it out, we got these two the same, the 3x's minus 5, so we could factor that out, and then we can multiply it by what was left over, the 3x minus y. In example number 7, we're asked to factor these 4 terms using the technique of factoring by grouping. So let us go to the whiteboard and work this out.
In example number 7, we're given 2x cubed plus 21 minus 7x squared minus 6x. Now in this one, it may be a good idea to rearrange the terms and in order to factor out, let's say, the x squared. So what I'm going to do is I'm going to rearrange the terms because we can do that. So we'll have 2x cubed minus 7x squared minus 6x plus 21. So here's my first group and here is my second group. And then here for this one, I'll factor out x squared. And then 2x minus 7. And then here, again with the signs like I did before, I'm going to factor out the negative 3 and 2x. And as I see when I when I distribute it, I'll get back my -6, and then I'll put -7 here because -3 and -7 will give me positive 21. So now I have these two factors the same. So I'll have 2x minus 7, and then I'll put the leftovers in the next factor, 2x squared minus 3, and now I have factored this expression.
We found that for this particular problem, it is best to rearrange the terms to factor out the x squared term. So we ended up rearranging it to factor out the x squared, and then we had the 2x minus 7 and the 2x minus 7 in common, and then we were left with the x squared minus 3, which we put in the other bracket. Thank you for watching this video. I hope that you enjoy it. So be well, take care, and bye for now.